So in this lab, we're going to be using tape to observe the transfer of charges, particularly electrons, from surfaces and how charges interact with each other. From the experiment, we're able to calculate the charge of the tape as well as estimate the number of electrons transferred in the process. The system will be tape B, as seen as the red tape on the right, and the surroundings will be tape A and the Earth. And I've included a couple helpful equations that's going to be utilized throughout the experiment, which is F is equal to ma, which is Newton's second law, and a will be the acceleration due to gravity, which is 9.81 meters per second squared, and then the electric force, which is Coulomb's law, which is 1 over 4 pi epsilon naught times q1 times q2 over the magnitude of the distance squared times r hat if you use the magnitude. So for my observations and results, I observed that the U-tape was attracted to my hand but repulsed the other piece of U-tape, and it was also attracted to a neutral meter stick and a book, as well as a negatively charged clear plastic pen. And from my experimental computational model, I found that the charge on one piece of tape is 1.34187 times 10 to the minus 8 coulombs. And the deficiency of electrons on one piece of tape is 8.38672 times 10 to the 10. And then there are 4.76945 times 10 to the 6 atoms for every electron on one piece of tape. And I'll show you the computational model that I created in just a second. So it is a little bit hard to see, but for the initial conditions, I'll go over that first. The tape mass is 0.00023 kilograms. The tape length is 0.2 meters. Tape width is 0.02 meters. G, which is the acceleration due to gravity I mentioned earlier, is 9.81 times meters per second squared. The distance between the two pieces of tape is 0.0268 meters. The atom length that we assume is 1 times 10 to the minus 10 meters. The charge of an electron, which is universally known, is 1.6 times 10 to the negative 19 coulombs. And the K constant, or 1 over 4 pi epsilon naught, is 9 times 10 to the 9, which in the code you could see is referred to as UFPES 99. You could see that. You could see Q electron, which is the charge of the electron, tape mass, tape length, tape width, G, distance, atom length, and the scale factor. And then we find the force of gravity, and the electric force is just the absolute value of the force of gravity in this instance. So then we're able to find Q because we know the electric force, and then it prints what it is, which you can see on the bottom is the model that it printed. It shows that then we find the atom count and the electrons to atoms ratio. And then at the bottom is where I've defined the objects like the red sphere, the blue sphere, the green arrow, and the orange arrow. So for the discussion, we have two major questions. The what if and what does it mean questions. So what if the signs of their charges were reversed like protons and electrons? So what if electrons were positive and protons were negative? What would we do about it? What would it change? And the answer is there's not going to be any change at all. Like charges are still going to repel and opposites would still attract. And I guess there will be a change, but the only difference is the tapes would lose protons instead of electrons. And then for the what does it mean question, it asks to compare the estimated value of the charge you get when you use your experimental data, which was the glow script model on the last slide, that produces a point charge model, and then the value you get with the line charge model, which is the piece of code that I've included on the right as part of it, the second code, and then the two computational values for Q. So the point charge model versus the line charge model, they're different. And why are they different, and which value is likely to be closer to the real value, and why? So in Model 2, the charge is more evenly distributed across the tape, as we know, because it's the line charge. Whereas in Model 1, we assumed that it was concentrated in the middle, hence point charge. It's concentrated in the middle, so we used it as a point right in the middle of the tape. And to me, that means that Model 2 is likely going to be more accurate to the real value, because in reality, the charge is going to be more evenly distributed across the tape, whereas in Model 1, we assumed that it was just in one particular spot in the middle of the tape. So that's what I think, and thank you for watching.